Chapter 11, we're going to talk about gases. So the first section is entitled Extra Long Straws. So we're going to have a chance to sort of revisit our childhood, which some of us may not have quite given up yet. The author talks about how he used to enjoy putting straws together. This is the sort of thing that a kid does at a restaurant while they're waiting for the food to come, because it's like incredibly boring to sit there with your parents, right? So you take the straws and you stick them together and you make this really long straw, and then you put your glass of soda on the floor if your parents will let you, and you drink it through this really super long straw. How long could the straw get? Could it be infinitely long? Or is there a finite length? These are interesting questions. Have you ever wondered, why do straws work? So when you suck on a straw, you're removing the air that's in the straw, right? So you're removing some air from the straw, and that creates a pressure difference between inside the straw and outside the straw. That causes the outside pressure to push the liquid up the straw into your mouth. So essentially the atmosphere is pushing soda into your mouth. So then it's not your fault if you drank 2 double gulps of soda in one day, right? The atmosphere made me do it? That's probably not going to stand up, is it? So it turns out that even if you had a perfect straw, no leaks, no holes, and rigid walls so it wouldn't collapse on itself, the highest straw, the longest straw that would work would be about 34 feet. Beyond that, you could pull a perfect vacuum on that straw. You would not be able to get a liquid any higher than 34 feet. What's magical about 34 feet? Well, we're going to learn about that. So we have to understand what gases do and what gas pressure is. So pressure is a force exerted per unit area. That's a physics definition. It's a force exerted over an area. That's pressure. The gas molecules in the air exert this pressure. We are not aware of it because we are accustomed to this pressure. If the gas pressure suddenly went away, we would notice that as we exploded. Yeah, that'd be ugly. So little tiny gas particles, and they're moving around and they hit things. And when they hit things, they exert a pressure. On Earth at sea level, which here in Fresno we're not much above sea level, the gas molecules in the atmosphere exert a pressure on everything around us, including ourselves. It's an average pressure of 101,325 newtons per square meter. Newton is a unit of force, square meter is a unit of area. Well, that's not a unit that we use much in chemistry. This is one you might be more familiar with, PSI. PSI is an abbreviation for pounds per square inch. Pound is also a unit of force. It's a force over an area, that's pressure. 14.7 pounds per square inch is the average pressure exerted by the atmosphere. So here we have an illustration of someone drinking orange soda. I'd make it Diet Dr. Pepper, but apparently the author likes orange soda. So here we have a straw sitting in a cup of soda, and the atmosphere is pressing down on the soda, both on the outside of the straw and on the inside of the straw, because the straw is open to the atmosphere. The pressure inside the straw is the same as the pressure outside the straw, right? Now, when you stick your mouth on the straw and you suck on it and take some of those molecules out of it, the gas molecules are what are exerting the pressure. You remove the gas molecules, or some of them, and you lower the pressure. Now the pressure inside the straw is lower than the pressure outside. And the outside pressure pushes the soda up the straw. It's opposing the force of gravity, which is pulling everything down. Any questions? Here we have another illustration. So here we have a perfect straw, and no leaks, and it won't collapse on itself. And here we have a strong vacuum pump, and we can even pull a perfect vacuum, get all the gas particles out of there. Remember, what's pushing the soda up into the straw is the force of the atmosphere pushing down on it. The difference in pressure between inside the straw over here and outside. Well, this is 14.7 pounds per square inch. The pressure exerted by a 10.3 meter column of orange soda, about 34 feet, is equal to 14.7 pounds per square inch. So when the soda has been pushed up 34 feet, 10.3 meters, the pressure inside now is equal to the pressure outside, and it won't go up any farther. That's kind of hard to think about, huh? Like, what? You can't just make it infinitely long? Do any of you live on a farm and have a well? Yeah. Where's the pump located?
Well, on top, it's out a ways away from the house.
But isn't the pump down partway down the shaft?
Oh, yeah.
Yeah.
Yeah, we have submersible pump that's on the
Yeah.
farm.
So the problem we're having with this severe drought is that the groundwater level is falling, and so people's wells are going dry. It happened to my mother-in-law. It's like one day, no water. Major money to get them to come out and drill a deeper well. You can't have the pump for the well sitting up on top of the ground, because then you would only be able to bring water up about 34 feet for this same reason. So what they do is they lower the pump, they put the pump down deep in the well. And now they're, putting pumps down like 100, 150, 200 feet below the surface so that they're close enough to the water level, or some of them are submersible, it can even be under the water level, that they can pump the water up. A pump can push water up, that's no problem, but you can't suck water up more than 34 feet. Does anybody have any questions about that? There's a lot of chemistry that you may not feel applies to everyday life very much. So I think it's fun when something really does.